So let us look at the last aspect of electric field, which is known as what? Gauss theorem. So the Gauss theorem. This theorem said that what? The electric flux that's coming out from a Gaussian surface is equal to the what? To the total charge over the permittivity of a free space. Let's look at it now. This states that the total electric flux, electric what? Flux coming out. What electric flux? The line, the feed line. That's what? Coming what? Out of a surface. Of a surface. And the surface, we always call it what? Gaussian surface. Go what? Gaussian so what? Surface. So the total electric flux that's coming out from a Gaussian what? Surface is equal to the charge Q enclosed by this surface divided by permittivity of free space. Free what? Free space. Actually, not what? E. So this is what? The Gaussian's what? Theorem. This man simply states that what? The total electric flux coming out of a surface, what is the surface? Gaussian surface is equal to the charge Q enclosed by the surface divided by permittivity of what? Of free what? Of free space. Mathematically. Let me, before I regard it mathematically, let me explain some things here. Assume that what? This is a spherical surface. Can you see it? This is a spherical what? Surface. This surface we have here is what we call what? Go what? Gaussian. Go what? Gaussian. Gaussian surface. So if you now place the charge Q here, the charge Q will place as inside the what? The spherical surface, which the surface is what? Is Gaussian. So the Gauss now said that what? The electric flow that's coming out from this surface will be equal to the what? The total charge inside the what? The surface divided by the what? The permittivity of free space. Assume that what? I'm trying to consider this region, small area here. So if I cut this small area out here, you will observe that what? The charge here will release what? The field. Will release the what? Electric what? Electric field. So this field electric field that is coming out from this side, this is what we call what? Field what? Intensity. No, this is the field intensity, right? But the amount of this field that is coming out here is what we call what? Electric what? Electric flux. I mean now, and this all this field coming out from the what? From this particular what region here, which is what? The area. I mean, so this is what? The what? The area of the surface. This is what we call what? What? The flux that is coming out. So according to the Gaussian, the man now said what? The electric flux, this is flux that is coming out from the what? Gaussian surface. The line of force that's coming out from what? From Gaussian surface is equal to the what? To the charge enclosed. That is what? Total what? Total charge. Total what? Charge. Q over what? Divided by what? By permittivity. Permittivity of free what? Space, which is what? E naught. So from this expression, we can now later learn to do what? The electric what? Flux to be equal to the Q total over what? E naught. This is what? The Gaussian theorem. In summary, the Gaussian theorem says that what? The electric flux that is coming out from a spherical surface is equal to the what? To the total charge we have inside the what? The surface divided by what? The permittivity of what? Of free space. This is the Gauss theorem. State that the flux that is coming out from a surface is equal, not surface must be what? Must be closed surface. Spherical surface, it may be cube, it may be rectangle, it may be what? Closed surface. And the flux, the number of what? Of flux that's coming out from the surface is equal to the total charge we have inside the surface divided by what? Permittivity of free space. That is what? Gauss theorem. The flux that is coming out, the number of field that's coming out from the surface is equal to the what? To the total charge inside the what? Surface over permittivity of free space. If charge here is 2, it will be 2q over what? If charge here is 5, it will be 5q over what? If it is 10, that is the meaning of what? Gauss what? Theorem. The Gauss theorem is another way of what? Of finding what? The electric flux. If you don't want to use what? The first one that we did at what? Heat intensity times what? As area. So the next aspect that I would like to treat now is the proving of what? Of Gauss theorem. So let's look at what? Proving of Gauss theorem. So in the proving of Gauss theorem, yes, I would like to redraw this diagram again. So if I redraw the diagram in this form, that is, we have a what? A Gaussian surface. So if this is the Gaussian surface, don't mind my circle. So assume if this is what? A Gaussian what? Surface. Assume if this is a what? A Gaussian surface. If a spherical what? Surface. I now place a what? A charge Q here. So if I remove a what? A region here, this region that is what? I remove a, let me call it what? The what? The area of the what? Of the region. And this charge will release what? Field that is coming out from what? From it to the what? To the outside. The what? The surface. So this fits the number of field line that is coming out from this particular region, as we all know before, is known as what? The electric what? Electric flux. And this surface, we call it what? What? Gaussian so what? Surface. Good. So from this surface now, we can now say what? Since, if you remember, scope, that what? Since, if you remember from electric flux, flux is equal to the what? E A. Good. Electric flux is a product of what? Field energy as what? As area. Abi, you can now say what? Then you can call it what? The flux. Abi now, E the what? The area. The flux, the area where field intensity is what? Is constant. So by continuing this, we will have what? Total flux. You can say what? Total flux here will be equal to the what? It will be equal to integral of the flux. Yes. It will be equal to the what? The integral, this integral symbol of what? The flux. So if the total flux is equal to the what? Integral of the flux. So here now, therefore, this expression can be in what? In the integral of the what? The flux is equal to the what? Integral of what? E the what? The A. So we can call this what? Equation what? Equation 1 of the proving. If you say what? Total power to what? Integral of the flux. Introduce integral to this side and integral to what? To the side. By doing that, by what? By doing that, you can now say what? Recall again that what? But E A is equal to what? What is this field intensity? Equal to what? KQ over what? Over R square. And don't forget again the area of the sphere. Area of the sphere A is also equal to the what? 4 pi what? Area of the sphere equal to the what? 4 pi R square. The area of this sphere is 4 pi R what? Square. Abi? So by doing that, multiply this together, you now have what? EA should be equal to the what? KQ. No. If it's no, wait. That's what again. Recall that K also equal to the what? K we add there. So it was 1 over what? 4 pi R. So 4 pi E naught. Epsilon naught what? E naught. This K, if you remember from the Coulomb law, I said K is 1 over pi, 4 pi E what? E naught. Which is the same thing as what? 9 times what? 10 raised to the power 9. Good. So you have put it here for the K. You will now have what? E A. God, what is the K here? So it will be what? 1 times Q. It will be Q over what? 4 pi E naught. This K is what? Is 1 over this times Q. E naught multiplied by what? This what? R square. Everything you have there. Then multiply by this A. This A which is what? 4 pi what? R cube. You now have what? 4 pi what? R square. This cancel this, good. This kill this, this kill this. We are left with what? PA should be equal to what? Q over what? E naught. Q equal to what? E naught. And where what? F the electric flux is equal to the what? E what? EA. Put it here. You now have what? Flux equal to the what? Q over what? E naught. This is the formula for what? Gauss theorem. If you have to put the Gauss theorem, you can prove it in this form, or you can also add it in what? Integral of E dA should be equal to what? Q, charge Q over what? E naught. This is another way of expressing the what? The Gauss theorem. So the next thing is what? Let's solve two or more questions on Gauss theorem. Very easy. Gauss theorem once again states that what? Electric flux that's coming out from the Gaussian surface, a spherical surface, is not must to be a spherical. It may be sphere, it may be cube, it may be rectangle. That box that's coming out from it is equal to the what? The total charge inside the what? The surface over what? The permittivity of the free space. Let's solve these four questions by applying the Gauss theorem. Solution. A charge. We have solved this question before. Under electric flux. So we must arrive to the same answer. So we can confirm it. A charge of plus what? Plus 2. We are given Q should be what? Plus 2 microcoulomb, which is what? 2 times 10 raised to the power what? Minus 6 coulomb. By enclosed by a sphere whose radius is this, and determine the total flux that's coming out of the spherical surface due to the what? The charge enclosed by it. We are given radius here. You can use the radius to find the what? The area. If you order to find the area, you apply this formula, which is flux equal to the what? EA. So this E, you know that what? Our E here is what? Is K, is the E. Yes, is what? K Q over what? R square. So, and then we have radius. Apply this, use this charge for this. The what value you get for E here, then find the what? Area of radius. Where area of sphere is 4 pi r square. We have done it before. So you get this. But I don't have interest in what? Of using this formula. I want to apply the what we call what? Gauss theorem. We are given this. And a Gauss theorem using Gauss what? Theorem. So that electric flux will be equal to what? The total charge over what? Permittivity of this space. What is charge given? The charge given is what? Is 2 times 10 raised to the power minus 6. Permittivity of free space. This one is constant. Abi, check your Coulomb's law. It's 8.85 times 10 raised to the power minus 3. Yes, 8.85 times 10 raised to the power minus what? 3. So if we divide it, at the end of the day, we are end up with what? The electric flux to be 2.66 times 10 raised to the power what? Minus 6 or 5 Newton meter square per coulomb. Check it. The answer must be the same with what we did first. So the second question, question number 2. We are given that what? A hollow spherical shell of radius 40 meter contain 2 points of charge what? Q, this, placed at the point of separated of 30 centimeter inside the shell. What is the flux of electric field due to the charge through the surface of the what? Of the shell? This is a multiple choice question. You can see that what? Our answer is in form of what? Of Gauss what? Gauss theorem, which say that what? The flux equal to the what? The total charge over what? The permittivity of free space. So we have our answer in this form. So from this question now, our major interest is the charge given. These two charge given. We are less concerned about the what? About the radius and the distance what? Apart. But we are asked what will be the flux of electric field due to the what? The charge through the surface of the what? Of the shell. So we are given that what? The charge, Abi, the first thing we need is that they place in the hollow shell. Abi now, if they place this in hollow shell, can I draw the diagram? Or as you solve it directly? They place this in hollow what? Hollow shell. We have how many charge? Plus 3 and what? Minus 3. So what will be the what? The way I did here, our total charge will be equal to the what? We are given plus 3Q plus minus what? Minus 3Q. If we add what? Plus 3 charge minus 3 charge, what is the total charge given? We have 0. Sum this charge together. The Gauss theorem says that what total charge we have, sum them together. The charge inside the what? The shell. 3Q minus 3Q. Sum them together. So the final answer you have, our total charge is this. Then from Gauss theorem now, what will be the what? The flux with the total charge enclosed in what? In hollow shell over what? The permittivity of free space. So the total charge in the hollow shell is what? Is Q, which is 0. Add the charge together over what? Permittivity. The final answer here we have 0. So which one is correct now? The answer is what? 0. Very easy. The option is in what? Gauss theorem. You have to find electric flux. So if you apply this theorem to this rule, you still get 0. But the total charge will give you what? 0. So the next question is what? Question 3. What is the question 3? 2-point charge plus 3Q and minus Q placed inside the cube of side X. The total electric flux through the cube is, yes, what is the what? Question what? 3, Abi? Our total charge. How many charge do we have here? We have plus 3Q. Say what? Plus 3 what? Dot plus 3 what? Q minus Q. What is the Q we have here? This placed inside the cube X. So if we add this charge together, plus 3Q and then minus Q to know your total charge that placed inside the what? A cube. Abi? So the total charge, add it together, it will give us what? Plus 2Q. So this is our what? Our total charge. Yes. You are now asked to find the what? The total electric flux. So the total electric flux will be equal to the what? The total charge enclosed in a cube over what? Permittivity of free space. What is the total charge enclosed? The total charge enclosed here is what? We have 2Q over what? Permittivity of free space. That will be the final answer. The answer here is what? Is B. So this is how you can apply what? The Gauss theorem to solve a multiple choice question. The next one is what? Find the center of a cube. Question number 4. No, they said at the center of a cubical box, charge Q is placed, the value for total flux that is coming out of the wall is, yes, I love this question. They said, let me draw a cube. If you look at the cube look like this. This is how a cube look like. Look at this cube now. Now said a charge Q is placed at center of the cube. So let me say this is what? The center of the cube that we play the charge Q2. This is the charge we play at the center of the cube. You are now asked the value of total flux that's coming out of the wall. What is flux? The feed line that is coming out from the what? From the, so if you look at this cube, how many faces does a cube has? Let's check it. This is up, 1. This one is what? Down, 2. This side is 3. This side is 4. This particular side here is particular side here, 4. This particular, there is a side here, other side. You have what? The side we have here, we have what we call what? 5. And we have another side here too, which is what? 6. And let me do it this way for the convenience sake. 1, there will be 2. So 1, 2. Yes, we have 3. Here will be 4. This place will be what? 5. Will be 6. So a for every cube has 6 sides. Check it like this now. We are in a classroom and the structure of the class is a cube. Let's count the number of sides we have, and I'm the charge that they place inside the what? The class. Abi, which is cube. Let's count the number of sides we have in what? In the cube or a class. Ceiling 1, floor 2. Abi, my right is what? 3, my left is 6. Front, sorry, up 1, floor, ceiling 1, floor 2. Right 3, left 4. Abi now, my front is 6, 5. My back is what? Is 6. So this is what we have here. That is now, if the what? The come out in how many sides? 6. One will go like this. The other one will go like this. The other one will what? Will come out like this. The other one will what? Will pass this. The other one will what? Will pass this. And the other one will what? Will pass this. We have 6. So the charge, the flux, the feed line that is coming out from the what? From the 6 surface will be what? Will be 6. Have you now? So if this the flux that is coming out here is 6, can I say what? Our what? From am I going to put it to? Is we have 6 what? We have 6 sides. You can now say what? From this, we have Q total over what? Permittivity. But note that how many flux? This is flux, 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 flux. How many flux do we have here? We have 6. So we now have what? 6 flux is equal to the what? Q total over what? Permittivity of this. We are now asked to what? Find the value of total flux that is coming out in a what? A wall. So in a wall now, it be what? A wall has how many what? Flux? 1. So here we have total flux is what? 6. So divide this, we now have what? This Q total over what? 6 Q what? E naught. So this is the what? The answer for this question. Answer is what? Is D. When a charge is placed inside at the center of the what? Of the cube. We are now asked to find the what? The flux on a what? Each wall. It will be what? The total charge enclosed over what? 6. The number of the side we have. What? That's the answer for that one. So you can help me to solve this and give me the answer on the comment section. What is the flux through a cube side corner? This one drop on this one though. A cube side what? Side corner. If a point charge Q is at one of its what? Of its corner. That is, instead of placing my what? My test charge at the center here, they put it what? At this point. Can you imagine? At this what? At this point is where they put what? The charge to. So if you want to check it now, in a cube, how many corners do we have? So the number of corners here that we have in a cube would determine the flux in each corner. Check it. In this cube now, we have how many corners there? 1, 2, 3, 4, 5, 6, 7, 8. Abi? This is a corner. This is another what? Corner. This is another corner. This is another corner, making 4. Another corner. Another corner. Another what? Corner. And we have another what? Corner. 1, 2, 3, 4, 5, 6, 7. It's 8, yeah? No, this one is not a corner. This is another what? Corner. Or if this is complex for you to what? Check the room you are now. Check it. How many eggs do you have here? Corner. We have 1 here. We have another 1 here, making 2. We have another 1 here. Another 1 here, making 4. Here, 5, 6, 7, 8. That's what we use to what? Calculate it. If it's 8, question number 5 now. Since we have 8, Q equal to the what? Q total over what? Over E naught. And then we have how many corners there? 8, Abi. So the flux equal to the 8 QT over what? E naught. So from there, electric flux in each corner will be what? Q total over what? Over 8 E what? E naught. That's the answer. Answer is what? Is D. Don't, if the charge placed at corner in a what? In a cube. Differ for when a charge is placed at the center of the what? Of a cube. That is all about what? Application of Gauss's what? Theorem in a multiple choice question. Thanks for watching.